In this video, I'm just going to tell you what Doppler shift is. Okay, and you noted, as you've heard race cars go by, right? It's the when they go by, right? This is race cars. If you're sitting still, this is moving source Doppler, and there turns out there's two types, right? And then if you've ever ridden a train and you sit on the train and you listen to the bells are of course sitting still, and you're moving. You're a moving observer, okay? And there's two different formulas for this one, but this is like as you pass those railroad crossings as you ride the train, right? You hear the ding 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 ding, right? And then this is the key to understanding this, is that if you're approaching the source, or if the source is approaching you, if they're getting closer together, then you have a higher pitch, right? The race car has a higher frequency, right? And if you're receding, if either the source is receding from you or you're receding from the source, okay, either one of these things would yield a lower frequency, right? The frequency is going to shift to a lower frequency, right? And of course, you can either be a moving source or a moving observer, okay? So what's going on here is that moving source Doppler actually changes the wavelength. If you're sitting still, of course, the waves are all the same length in all directions, right? These circles should be round, but you know, when I change the aspect ratio of this PowerPoint to match the screen, it very magically changed their aspect ratio. Okay, if it's moving though, do you like that sound? I like that sound, right? That's the sound, right? Okay, if it's moving to the right, it actually will shorten the wavelengths. The actual wavelength in the air for moving source is shorter in front and it's longer in the back. I've got a really good little thing I can show you for this in a sec, right? And then moving here, let's just go to that. Let's see if we can. There it is. Oh, nope. Let's go there. Oh, here we go. Here it is. Okay, so take a look at this. I'm going to reset this and hit start, and you can see it's drawing a little animation. You can see that in front here, those wavelengths are all shorter than the ones behind, and that's because as it moves to the right, it shortens the ones in the front, lengthens the ones in the back. Notice that all these circles are circles, right? It's just that they're not concentric. Because it's moving to the right, it actually shortens that one in the front. Okay, so let's go back to, whoops, I keep doing that, there. Okay, and then the other one is moving observer. Moving observer is the wavelength actually is the same, right? And the observer moves into it. As they move into the front's higher frequency, away from them, then they get a lower frequency like that. Okay, so that's what's going on. That's the basic idea. In the next videos, we're going to derive the formulas for these things. Okay.